All right, so today we are going to be graphing the two radical functions, square root functions and cube root functions. We are graphing two of them, okay? So square root functions are going to be in the form f of x, which is just another way of saying y. F of x equals square root x. So if you did not get to print the notes, then you should be writing square root parent function, f of x equals square root x. And then we're going to go ahead and make a table for this. And what are some numbers that we would like to square root? Can we square root 0? Yeah, and we can square root 0. What's the next smallest number that is a perfect square? 1. 2 is not a perfect square. What's the next smallest perfect square? 4. And then what's the smallest after that? 8 is not a perfect square. 9. What's the next smallest perfect square? 16. What's the next smallest perfect square? 25. Okay. So what happens when you square root 0? You get 0. What happens when you square root 1? What happens when you square root 4? 2. When you square 4, you get 16, but when you square root it, you get 2. What happens when you square root 9? 3. What happens when you square root 16? What happens when you square root 25? Okay. So we're thinking about taking these perfect squares and plugging them in here. So square root 0 is 0, square root 1 is 1, square root 4 is 2. Madeline, I'm so sorry, but we're going to boot you up here to this desk. Joey or Hot Dog, would one of you please grab one of those extra chairs and bring it up here for Maddie? Thank you. What a gentleman. What a gentleman. All right. So we got 0, 0. Madeline, I'm sorry I called you Maddie. It was an accident. All right, so we got 0, 0, we got 1, 1, we got 1, 2, 3, 4, 2. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. That's about as far as we're going to go, because the other ones we'd have to make it like such a big graph to be able to do it. We are not going to plug in any negative x values, and can somebody tell me why we're not going to try any negative x values? Yeah, you're not supposed to be able to square root a negative. That's where the I comes in, and we don't graph imaginary things. We can barely work with them. We put an I in there, and we're like, it's imaginary, it's fake. Like, you can write it down on paper, but it doesn't really mean much to us. We certainly don't graph it, because how do you graph something that's fake? Yeah. Okay. So the end point is this point right here. The graph stops right there. So on the parent graph, the end point is 0, 0. The domain are the x values that we can have. So we have, I'm going to write it two ways. So I'm going to say my lowest x value is 0. So I'm going to say x is greater than or equal to 0. Or we can do that other notation. So we can say the furthest left that you can go is 0. The furthest right that you can go is an arrow. So that's an infinity. 0 is an actual point that I can see. So that's going to be a bracket. An arrow, I can't quite put my finger on that, because even though I can put my finger on an arrow right here, I'm actually on the number 11, right? That's where my finger actually is. And so that's a controversial topic right there. It was a virus. Anyway, I don't know. Anyway, so I can't really put my finger on infinity because even when I put my finger on the arrow right here, I'm actually putting my finger on 11, not infinity. So I'm gonna put a parenthesis right there. Okay, and then the range is the y values just from bottom to top. Same thing, the lowest output that I have is 0. So the y values are just y is greater than or equal to 0. So the very lowest the graph goes is 0, the very highest the graph goes is infinity. It's actually the same answer. Just instead of left to right, it's down to up. Okay. How are you guys feeling so far? Good? Feeling okay? All right. Those of you who are doing graph paper instead of the notes, are you keeping up okay? Graph paper people? Okay. All right. Next, we have the cube root parent function, which is f of x equals the cube root of x. F of x equals the cube root of x. Okay, so let's think of those perfect cube numbers if you still have your little chart thing. So we've got 0. We got negatives here too. We always forget about the negatives. Okay, I'm going to put 0 in the middle. So what numbers can we take the cube root of? 1. Okay, so I've got 1 and negative 1. What's next? Yeah. 8 and negative 8. And then what's next after that? Not 16. 27. 16 is a fourth root. You can fourth root 16. So 27, and then I'm negative 27. I didn't leave myself enough space up here. I gotta write it real small. Okay. All right, so the cube root of 0 is 0. Yeah, 0 times itself 3 times is just 0. What's the cube root of positive 1? What's the cube root of negative 1? Negative 1. Okay. What's the cube root of 8? 2. What's the cube root of negative 8? Okay. What's the cube root of 27? What's the cube root of negative 27? Okay. All right, so I got 0, 0. I got 1, 1. Got negative 1, negative 1. Got 8, 2. Negative 8, negative 2. Okay. And then the 27 and the negative 27, I can't really draw those. So this part looks like the same as this one, but just like not, it doesn't go up as high. It's a little bit more squished, compressed. And then it has a left side, which the other one doesn't have. Yeah, it's a little wave. Okay, so they call it a turning point, this middle point right here. That's 0, 0. When you get into Math 3, I call both of these so that I don't have to have a different name for them. I call them both the locator point, just because it's easier. As like, oh, that's the definitive point on both of them, so they have the same name. So different people call it different things. But so it's kind of like the equivalent, you know how on the parabola we had the vertex? The endpoint is the square root graph version of a vertex. The turning point is the cube root version of a vertex, and in Math 3, I just call them all locator point. If either it's a vertex or a locator point, and then that way it's just an easy name to just kind of be different. All right, the domain on this one, what do you guys see? We got negatives and positives this time. All real numbers, okay. Or what if we do the interval notation? Yeah, negative infinity to positive infinity. It's got that left arrow and it's got that right arrow. Okay. What about the y values? You can look at the table too if that helps. So this time we're going up and down. It looks like it doesn't go up and down as much, but we're still seeing arrows. So what do we notice? All real numbers, yeah. All real numbers again, or negative infinity to positive infinity. All right, how do your brains feel? Brains are okay? Brains are good? Okay. All right, next we have the word transformations. This is going to bring you back a little bit of deja vu with the quadratics. So here they're talking about the A, the H, and the K. Remember that? Okay, do you guys remember what the H does? This is inside, so this should be a little bit of a flashback to last unit.
How far it goes, like, to the left.
H is the horizontal shift. H is the horizontal shift, and H did something weird.
Oh, it's right as negative.
So positive shifts left, and negative shifts right. So this side does the opposite of what you would think. That's like the weird part about it. It is very weird. I always think of it as like, if it says minus H, you have to do the opposite thing to like bust it out of the parentheses or bust it out of the square root. So if it says like -5, you have to plus to bust it out. And that's why it's the opposite. All right, the K, the number on the end, is a vertical shift. Okay. Is there anything about the K on the end? No, it does what you would expect. So the plus shifts up, the minus shifts down. It does the thing that we would expect it to do. Okay. The end point, the turning point, I'm going to write vertex underneath. It's not called a vertex, but it's going to remind us of the vertex. And that is H, K. Okay. If the A value is negative, the function is something across the something dash something. Reflected across the x-axis. Okay. So if the absolute value of A, so they're saying it doesn't matter if it's negative, they're just saying if the size of the number is bigger than 1, that's a vertical stretch. And if it's less than 1, it's a vertical compression. Okay, so I'm going to sit here for a second, just leave this up here for those of you who are writing it down because I know it's taking longer if you didn't have the notes printed. Is this bringing you back to last unit, helping you remember, like, oh yes, we've done this before? In Math 3, we do this with like 7 different functions. We do it over and over and over and over and over again, and just when you think we're done, we're not. We do it 2 more times. We do it for absolute value. We do quadratics again. We have a unit where we do it for like multiple parent functions. So we review square root, cube root. We do exponential, logarithmic. We do rational. We do trigonometric. Is that all of them? Cubic. We do cubic. We do all the functions. We do all of them. You get to the point where you're like, yes, Miss Rice, I get it. These are the transformations. Let's move on. All right, so let's describe the transformations down here. Can we do that? Okay, so for number one, I'm going to put PF. That's going to be for parent function. We're just going to say if it's a square root or cube root, okay? We're going to say if it's a square root or cube root, then we're going to say the transformations. So for number one, what is the parent function? Square root, okay? And then what are the transformations? Perfect. Okay. All right, what's the parent function for this one? Cube root. And what are the transformations? A vertical stretch and down 1. Okay? What's the parent function? There's no such thing as a negative square root. Yeah, it's a negative in the front, yeah. The parent function, cube root, okay. And what's the transformations? Okay, reflect over x, left, 3, okay. What's the parent function? So what are the transformations for this one? Okay. Okay. Brains are good? Okay, okay. Okay. All right. So here it says the square root parent function is reflected across the x-axis, shifted 7 units to the left, and down 1 unit. Write an equation. Okay, I'm gonna write y equals. A lot of students forget that. We got to make sure we got that. That's important. Okay, so how do we write this? We do negative in the front because it says reflected over the x-axis. X plus 7 because it's the opposite of what you would think. Minus 1 on the end. Okay, do we agree with that? Okay. You can do f of x. Mm-hmm.
F of x is stupid, man. There's no point.
It means a function in terms of x.
If it means y,
Is there a function
then
of
y or
is there an f of y?
You could do a function in terms of y. So the reason that people use f of x or g of x or whatever is kind of the idea that we all have different names so that you don't get us confused, you know, because if everybody in the room was named Macy, then we'd have like
I think we have this exact conversation.
then we'd have like Macy number 1, Macy number 2, Macy number. We'd have to have some way of differentiating between the different Macys. So they name functions, they name equations different things so you can differentiate between them. So you could have f of x, you could have g of x, you could have y. That way you can think of them as like names of different equations. So you could say this one's f of x, this one's g of x, and then you can compare them. Oh, f of x has a y-intercept of this, g of x has a y-intercept of that, instead of saying like the first equation, the second equation, which would get people maybe confused. If they have different names, then they're easier to refer to. Yeah. All right, let's do number 6. A cube root function has a turning point, think of it as a vertex, located at -2, 3. Write an equation that could represent the function. So we're not allowed to put extra stuff in there, so we can't put a negative in the front, we can't put like a vertical stretch on it, we can't put a vertical compression on it. So we can't add extra stuff. Yeah. Cube root x plus 2 plus 3. I almost completely agree with you. Didn't you say x plus 2? Y equals. Should it be minus 2? Should it be plus 2? Should it be minus 2? So it should be plus 2 because for them to get here, they had to move to the left. and this means left. Does that make sense? So if you graph this turning point, everyone listen carefully because this is going to mess with your brain. For them to get to that turning point, they had to go left 2 and up 3. So if they had to go left 2 and up 3, then this means left 2, up 3. So it must be plus 2 plus 3. Whew. Okay. All right. So I'm going to go ahead. I'm going to write number 7. I'm going to write it slightly differently. Now, they called it the end point. Well, end point or turning point. What is it for this graph? It is 0, 5. So the end point or the turning point for this graph is 0, 5. So for these ones, we're actually going to use our calculators to graph them. But before we graph them, we're always going to find the end point or the turning point first. And then we're going to look for that on the table, okay? So 0, 5 is the end point or the turning point of our graph. We're going to always look for that first because that's going to tell us either where the graph starts for a square root function or where the middle of the graph is for a cube root function. So that point is going to be important for us. Does that make sense? It's either where the graph starts or it's where the middle of the graph is. So we got 0, 1, 2, 3, 4, 5. So square root x plus 5, and then you can type it. When you type it in your calculator, you can type it in the original way, or you can type it in with the plus 0, plus 5. It doesn't matter. They're both the same. So this is what our graph is going to look like. I am not going to try to graph it from that. It won't be accurate. So I'm going to go to the table, and I'm going to look for 0, 5. And then I'm going to look for points that are easy to graph, which means I'm not going to graph the decimals. I'm going to look for the whole numbers. Okay, so there's 0, 5. Then I've got 1, 6. And then I'm going to skip the decimals, and I got 4, 7. Maybe one more if I can get it in there. 9, 8. Okay. Yes. So I graphed it, and then I hit second graph. And that's how I got to the table. And you're always gonna, the first point on the table that you're gonna look at is gonna be the end point or the turning point. So did you have 0, 5? Did you get the plus 5 not underneath the square root? You square root x and then plus 5? Let me bring it up here, Jack. Oh, it's because your table goes by 5s instead of 1s. There you go.
Oh, lovely. Thank you.
All right. So our domain, what's our lowest x value? That's a y value. What's our lowest x value? 0. So we're going to say x is greater than or equal to 0, or if you're doing the other notation, what are we going to write? What is it? Perfect. Okay. Now, the range on this one is a little bit trickier because we did shift the graph up, right? It's got a +5 on the end, so we shifted it up. So what is the lowest coordinate for the y? 5. So the range is that y is greater than or equal to 5. So how do we write the range? Yeah, very good. And remember from last time, you do not have to write both notations. You can choose one or the other. You do not have to write both, okay? End behavior, I think, is overkill for Math 2, so we're going to get rid of that. You can learn that in Math 3. You do not need to learn it now. Okay, increasing interval. We're going to stick our stick figure right here. And remember, increasing and decreasing interval is x values only, not y values, just x values. So what is the x value right here? Not the y value, just the x value, 0. What is the x value over here? It's an arrow, it's an infinity, it's an arrow going to the right. Now, is my stick figure walking uphill or downhill? Uphill, so is he increasing or decreasing? Increasing. So what we're going to do for decreasing is we're going to write none. He's not decreasing this time, okay? Now the word increasing is between what two numbers? 0 to infinity. And so we are going to say increasing from 0 to infinity. I always put parentheses. There's a lot of, in upper levels of math, they start to debate whether you can put brackets for things, but you can always put parentheses and they will always count it right. So you just don't even worry about it. Just do parentheses, you are good to go. All right, how do you guys feel about that? Okay. All right, let's try the next one. So let's find our endpoint or turning point first. So let's look at the numbers. This one's a little trickier than the last one. Yeah, perfect. 1, -4, so it's +1. It's the opposite of what you would think, and then -4. +1 and then -4. And so when we type this in the calculator, that is what we're going to look for on the table. +1, -4. That's what we're going to look for on the table. So there's my +1, -4. And then from there, I'm just going to look for the next couple points that I can graph that are not decimals. So I got 2, -3, 5, -2. 10, -1. All right. How you guys feel about graphing that? We're good? Think about that. So if we look at the domain, what are the x values that we can have? Greater than or equal to 1. Okay, so we're going to say, for the other notation, we're going to say from 1 to infinity. Okay, what's the range? -4 to infinity. We're going to not do end behavior. All right, let's do our stick figure. We always do x values for this. So what is the x value right here? 1. What is the x value over here? Okay, what is our stick figure doing? Increasing. He is walking uphill. If he was biking, that would not be fun. That's when you're biking, breathing very hard. So what should we write for decreasing interval? None. And what should we write for increasing interval? 1 comma infinity. I'm going to do parentheses because for increasing and decreasing, I just always do parentheses. Okay. Okay, I'm going to skip 9. We're going to put an x through 9. There's so many example problems. Gina always gives us so many. Do we always really need to do all of them? I mean, if you already done it, that's fine. We're just not going to do it as a group. Okay, did everyone have a chance to write down number 8? Okay. We're going to do number 10. All right. End point, turning point, what is it? 2, 3.
When graphing, do we put a negative or a minus?
In the calculator, you put a negative in the front, underneath the 3. Anytime you type it in the front of something, you have to do the little negative button. Okay, so there's the 2, 3. The next point is a 3, 2. Six, 1.
No, it's just going down.
Yeah, can you see why I wanted to do this one next? Because it's different. It's different than the other one. It's like we had done 2 of the same. We didn't need to do 3 of the same. Because this is going to change some of our answers in a way that number 9 would not. This point over here was 11, 0. I graphed it anyway. So there's my table. Okay. Okay. What is the domain? X is greater than, it's still greater than because it's still going to the right. Okay, now what about the range?
Y is less than or equal to 3.
Okay, y is less than or equal to 3. Or if we wrote it the other way. Okay. All right, now let's go ahead and do our increasing and decreasing interval. So I got my little stick figure. what's my x value? 2, infinity, and then what's my stick figure doing? Decreasing. So for increasing intervals, I'm going to say none. For decreasing intervals, I'm going to say 2, infinity. Okay. So that one was slightly different. Just slightly. It changed the range. It changed the increasing versus decreasing intervals. Okay. Now the next one is going to change everything because it's going to be a cube root. Yeah. Okay. So what is our turning point? -3. -3, 2. -3, 2. So that's what we're looking for on our table this time. Now, anyone remember how we get a third root? Hit the math button. Math button, you can do 4, or if you typed a 3 first, then you could do 5. Okay, x plus 3 plus 2. And we're looking for -3, 2 on the table. There we go. Now this time we have to go in both directions. We have to go up and down. There's some symmetry to these graphs, okay? So remember that these graphs have some symmetry to them. So -2, 3, 5, 4. And then in the other direction, I had -4, 1. I don't know if I have room for the other point. -11, 0. Okay. Okay. So what are the domain and range? They're all real numbers. We got left arrow, right arrow. And then if we think of it as up and down, we got down arrow, up arrow. Okay. So I put my little stick figure for my increasing and decreasing intervals. It's x values, so it's a left arrow to a right arrow, which means -infinity to positive infinity. And how is my stick figure walking? Uphill or downhill? Yeah, it's like slightly increasing, then it gets steep, then it levels out again, but it's increasing the whole way, right? It's just different types of increasing. So it's like you're walking on a path and you feel an incline, but it's not like a steep incline. And then it's like the type of increasing that's making your calves burn like real bad. And then it's at the type of incline where you feel it, but you don't feel it as much. Does that make sense? So it's increasing the whole time, it's just not the same type of increase all the way. Does that make sense? So for decrease, we're going to put none. And for increase, we're going to put -infinity to infinity. All right, before we do the next one, I'm going to rewrite it to help you guys find the turning point. Okay. So what is the turning point? 0, 0. So you can plug in the version with the zeros, or you can plug in the version without the zeros. It does not matter. You guys see the vertical stretch on this one? Yeah, definitely see it. For those of you working ahead, I do not think we're going to do example 13. I don't feel like we need to. So once you're done with this example, if you want to go straight into working on your assignment, feel free to do that. Oh, everybody's switching over. Okay, what's the domain and range? All real numbers. Double bar R. All right. Went ahead and put my stick figure on there. Put my infinities on there. What's my stick figure doing? Definitely going down. Decreasing negative infinity to infinity. For increasing intervals, I'm going to put none. All right. Put a little X through 13. We're not doing that one. Okay, so your notes are done. You can go ahead and get started working on the assignment. Make sure your work from yesterday is in piles on your desks. I will be coming around to pick that up in a little bit.